When investigating the behavior of light, it is important to conduct experiments in a dimly lit room. The reduced ambient light allows the effects of light refraction and reflection to be observed more clearly, without interference from external light sources. This controlled environment helps in accurately studying how light interacts with various materials, revealing the subtleties of how light behaves when it encounters different surfaces and substances. To investigate refraction, transparent materials such as glass or plastic blocks are used. By shining a narrow beam of light, such as from a ray box or a laser pointer, at an angle onto the surface of these materials, you can observe how the light bends as it enters and exits the material. When the light beam enters the transparent block, it slows down and changes direction due to the material's optical density. This bending of light is refraction, and it can be observed by tracing the path of the light before it enters the block, within the block, and after it exits. Typically, the light will bend toward the normal line, a perpendicular line drawn at the point where the light enters the material when it enters the block, and then bend away from the normal as it exits back into the air. By measuring the angles of incidence and refraction, one can calculate the refractive index of the material, which is a measure of how much the light is slowed down compared to its speed in a vacuum. Different transparent materials will refract light by different amounts, and these differences can be observed by repeating the experiment with various materials and comparing the angles of refraction. In addition to refraction, investigating how different materials reflect light can reveal how surfaces interact with light in varying ways. Different materials, whether they are smooth and shiny like a mirror or rough and matte like paper, reflect light to different extents. To investigate reflection, you can shine a beam of light onto the surface of different materials at a specific angle and observe the reflected light. The amount of light reflected depends on the nature of the surface. A smooth, polished surface like a mirror will reflect most of the light in a single direction, creating a clear, sharp reflection that follows the law of reflection, where the angle of incidence equals the angle of reflection. This is known as specular reflection. In contrast, rough or uneven surfaces cause the light to scatter in many directions, resulting in diffuse reflection. This means that the reflected light is spread out and does not produce a clear image. For example, when light shines on a piece of white paper, the surface's rough texture scatters the light in various directions, making the paper appear uniformly bright without any defined reflection. By comparing the reflection from different materials, one can observe that the degree of reflection varies based on the smoothness and texture of the surface. Conducting these experiments in a dim room enhances the visibility of light beams and reflected images, allowing for more accurate observations. By using transparent materials to study refraction and comparing how different materials reflect light, these investigations provide a deeper understanding of how light behaves when it interacts with various surfaces, demonstrating key principles of optics and the properties of materials.